Hello, I am Gopakumar. Welcome to your math tutor. Here we focus on helping you to solve the problems in engineering mathematics in the easiest possible way from an exam point of view. If you are interested in theory, then check out NPTEL. Evaluate integral 0 to infinity x sin x by x square plus a square dx. In case of contour integration, generally the most critical aspect of solving the problem is identifying the type of the given question. Minus infinity to infinity f of x by g of x cos ax dx, or minus infinity to infinity f of x by g of x sin ax dx, where f of x and g of x are polynomials such that the degree of g of x exceeds that of f of x by at least 1, then the question will be type 3. Another important thing to note here is, if the question is of type 3, we consider only the poles which are above real axis. That is, we have to find the residues of only positive poles. Since minus infinity to infinity x sin x by x square plus a square dx is the question of type 3, then minus infinity to infinity x sin x by x square plus a square dx can be written in the form integral z into sin x is the imaginary part of e raised to I z by z square plus a square. Infinity to infinity x cos x by x square plus a square dx, x by x square plus a square dx, then we would write it as real part of integral z e raised to I z dz. We know that equal to cos theta plus I sin theta. Cos theta is the real part of e raised to I theta, and sin theta is the imaginary part of e raised to I theta. Poles are given by z square plus a square equal to 0. Then z square is equal to minus a square, which is equal to plus or minus root of minus a square. Then we get the poles z is equal to ai and z is equal to minus ai. In type 3, we find the residues of only the poles which are above real axis. F of z equal to z e raised to I z by z square plus a square becomes z e raised to I z by z minus ai into z plus ai. To find the residue of z is equal to ai, use Cauchy's residue formula. Limit z tends to ai, z minus ai, f of z is z e raised to I z by z plus ai into z minus ai. Cancelling z minus ai terms and substitute z is equal to ai in the remaining z term. Z is ai, e raised to I z becomes e raised to I into ai by z plus ai becomes ai plus ai. Then ai into e raised to minus a by ai plus ai is 2ai. Cancelling ai terms, then we get residue e raised to minus a by using Cauchy's residue theorem. Integral f of z dz equal to 2 pi I into sum of residues. Then minus infinity to infinity x e raised to ix by x square plus a square dx is equal to 2 pi I into sum of residues. Here the residue is e raised to minus a by 2, and cancelling 2's, then we get pi I e raised to minus a. Minus infinity to infinity x into e raised to ix is cos x plus I sin x by x square plus a square dx equal to pi I e raised to minus a. Minus infinity to infinity x cos x by x square plus a square dx plus in I into integral minus infinity to infinity x sin x by x square plus a square dx is equal to pi I e raised to minus a. Comparing imaginary part on both sides, then we get minus infinity to infinity x sin x by x square plus a square dx equal to pi e raised to minus a. We have done the integration for the limit minus infinity to infinity. But here in this question, the limit is 0 to infinity. Since minus infinity to infinity x sin x by x square plus a square dx is an even function, then 0 to infinity x sin x by x square plus a square dx is equal to pi by 2 e raised to minus a. Suppose if the question is minus infinity to infinity cos x by x square plus a square dx, then we compare real part on both sides. Then minus infinity to infinity x cos x by x square plus a square dx is equal to 0.